Okay, so in the last session, we have discussed about matplotlib library. Also, we have talked about NumPy and Pandas libraries, which are very much important libraries as far as the machine learning is concerned. And also, we have discussed basic Python programming and advanced Python programming concepts. So, we have understood the syntax of Python, how the codes are written in Python programming, and also we have discussed how to use some special libraries in Python, such as NumPy, Pandas, and Matplotlib. Now, as far as the NumPy is concerned, it is related to the array handling. When I talk about pandas, it is all about the cleaning of data sets and processing CSV files. And when we talk about matplotlib, it was all about visualizing the data set or the information we have in terms of graphics or in graphical form or in pictorial form. So in this lecture, we are going to understand about the fundamentals of machine learning. So what is machine learning? What is artificial intelligence? What is deep learning? And differences between all these technologies and the similarities between all these terms. Also, we are going to understand about the classification of machine learning, different algorithms that we can use in machine learning. Basically, up till now, we have developed some skills to deal with machine learning. So, we have prepared ourselves to face the machine learning problem statements. Initially, we have understood the programming language which is required to write machine learning algorithms or to solve machine learning problem statements. After that, we have discussed some libraries that will help us to face the machine learning problem statement or to solve some machine learning problems. So, such as NumPy library, Pandas, and Matplotlib library will really help us to deal with machine learning problem statement. So, it could be a stock price prediction, or it could be rainfall prediction, or it could be any problem statement which uses the machine learning concepts or deep learning concepts. So, we will take help of the programming language which is Python, and also some libraries that we have installed, and we have uh, got familiarization with those libraries called NumPy, Pandas, and Matplotlib. So we'll take help of all these stuff, and we'll understand what is machine learning. So number one thing is the there are three important terms. Now, number one is artificial intelligence, number two is machine learning, and number three is deep learning. So many times we get confused about these terms, or sometimes we do not understand any kind of difference between AI, ML, and DL, the deep learning. So most of the times we understand that all these technologies are similar to each other, or all these techniques. It's just a single name given to the three names belongs to one single category only. But this is not true. There are some sort of differences as far as the artificial intelligence, machine learning, and deep learning is concerned. So, as far as artificial intelligence is concerned, any technique which will enable computers to mimic human behavior is nothing but artificial intelligence. So, by any way, if you can mimic the human behavior, so how humans think, how humans work, how humans respond to certain situation, if you can mimic this human behavior into machine, now that term is called as artificial intelligence. And this is not the new technology. Firstly, it was introduced in 1956. So it's around 75 years, we can say. It's older technique, but recently it has got popularity due to the amount of data now we are having. Previously, in 1956 or in that particular years, or even before 2000, we can say, we were not having digital data. So right now everything is digitalized, everything is available online, and everything is, we can say, for anything, we can say our data is online. As far as the we can consider our social media and all the platforms, when the shopping malls and other marketing agencies are collecting the data, and everything is online. Even the agriculture, in that particular domain, the whatever land and their measurements and their whatever the documents are, now they are digitalized and they are also online. So we are having tremendous amount of data, and as we are having huge amount of data, AI, ML, and DL algorithms can predict more accurate results than the previous. But in 1956, we were not having that much data to deal with. So, due to lack of data, the algorithms were not accurate, and that's how the artificial intelligence and other techniques were not that much popular when I go back into the history. Now, the machine learning is the term. It is something which is originated after 1980s, and here the it is actually, if I have to define in a simple language, it is subset of artificial intelligence. It is more advanced discipline of artificial intelligence. Here, job is not just to mimic the human behavior, but the machine must learn the ability of human beings. So of learning ability of human being, if you can implement that thing in the machine, then that could be machine learning. uh, in a simple language, in day to day life, we learn from our past mistakes, we learn from our experiences, we learn from our data. So we learn reading, we learn swimming, speaking, or any, even we learn languages, or even we learn so many skills in day to day life. So how we learn, if you can implement this process into machine, so that the machine will learn from his experiences, if the machine can learn from the past data or whatever data sets available to it, so in that case we will say that it is machine learning. So it is the subset of artificial intelligence where we are mimicking or we are replicating human behavior into machine, but this time machine has ability to learn from the data or from the learn from the previous experiences, just like human beings. As human beings learns from the past experiences, data available, the machine should learn in the same way. And if you can implement that thing into machine with some algorithms, of course with some coding and programming, in that case that will become the machine learning. Now next is deep learning. Now again, it is more advanced technique, and it is subset of machine learning. So machine learning is the subset of artificial intelligence, and the deep learning is subset of machine learning. So here we are trying to replicate or to create artificial brain. When I say deep learning algorithms, we are trying to implement the human brain with all its complexity, capability, and powers into machine. Right now we haven't achieved that thing, but yes, we are moving in that direction, and after a few years we'll be reaching that milestone also, and the technology will implement entire human brain with all its complexity and capabilities into machine. So that is deep learning. So nowadays we heard about the self-driving cars or Tesla and other stuff. So there somewhere the deep learning is playing the major role. So this is basic difference, and as you can see here, the deep learning is also the subset of machine learning, which is again the subset of artificial intelligence. So broadly, the artificial intelligence is a broad term under which machine learning is some subset, and under which deep learning is another some subset. So deep learning, as per the today's technology is concerned, the deep learning is the most advanced technology, which is all about implementing human brain with all its capacity. So implementing human brain with all its complexity and capacity with inside the machine, if you can do that, that will be deep learning. Okay, so artificial intelligence is all about mimicking the human behavior into machine. Machine learning is all about implementing learning ability of human beings into machine, and deep learning is all about implementing entire human brain with all its complexity and capabilities into machine. Right now we haven't achieved the complete replication of human brain into machine, as it is very much complex, but we will be doing that in future, and the technology is moving in that direction. So AI is all about mimicking the human behavior into machine, and there can be some approaches like rule based system or some expert system. So rule based system means there are some certain rules. For example, we can consider a very simple example, implementing some sort of intelligence inside the machine. Let's say we create a smart door, and that door will open whenever somebody appears in front of that door. So here some rule is set that if some person is detected, open the door. So this is rule based system. So certain rules are defined to operate that thing or to mimic the human behavior. For example, if somebody comes in front of your door, or if somebody hits the doorbell, you will go and you will open the door. This is what the human behavior is. But what we want to do, this human behavior we want to implement inside the machine. Now in order to implement that thing inside the machine, we will put some sensors and actuators, and that door itself will sense somebody is there, so there will be no need of doorbell. uh, as far as the human beings are concerned, in order to generate some sort of signal, we need or audio signal, we need doorbell, so that we will understand that somebody is in front of our door, so we have to open that door. But in case of a machine, the machine will having the electrical signal or the sensors data, and that will identify that somebody is there. And the human behavior of opening and closing that door will now be done by the machine. But for that there is some rule. If somebody is in front of the door, then only open the door. If there is nobody, then don't open the those such kind of systems can be considered as a simple AI based systems, which are very much basic, where we are implementing the human behavior. So AI means getting a computer to mimic human behavior in some way, any way you can consider. But if the machine is doing the human's task, that is AI. If the machine is mimicking the human behavior, how human think or how human behaves, in that case it is machine learning. So, or sorry, it is AI, artificial intelligence. But this is not sufficient, and this is not suitable in some applications, because AI sometimes uses hard coded algorithms or fixed rule based systems, which will fail in some cases, such as image recognition, face recognition, or extracting meaning from the text. If you type some paragraph and job is to extract meaning from that particular paragraph, then in that case the fixed rule based system or AI based algorithms, hard coded system, will fail there or will not generate the accurate results. So here the solution can be, we have to not just to mimic the human behavior into machine, but we must mimic how human learns from the data available, how we learn. For example, we learn driving a car. Now we keep on learning day by day. We just take we understand our uh, past experiences, and based on the data, based on some instructions, we keep on learning. So this is continuous learning process. So in that way the machine must learn from its past experience or past data. So in that particular way, if we can implement the learning ability of human beings into machine, then that could be machine learning. So all the algorithms we are going to develop for machine learning, we are basically targeted towards implementing learning ability of human beings into machine. And if we can do that, that will be a machine learning, and we'll understand all this stuff. Now, as far as the deep learning is concerned, so this is number one picture, and this picture is of dog. Now you will, by watching this picture only, you will say that this is dog. Now how you identified that this is a dog? You haven't seen this dog before, but still you can remember, or you can say that this is dog. I'll show another picture. You can still remember, or you can still identify this picture as a dog. And if you show you another picture, now this time the dog is having some clothes. The second picture is the dog is having some, or dog is sleeping on the bed. And the first picture is dog is walking on the road. So even the dog is covered with some clothes, or even the dog is sleeping on the bed, which is not the normal behavior of the dog, but still you can identify that this is the dog. Even all these pictures are dog. So how this is happen? Your brain is actually capable of implementing or processing the deep learning algorithm. So your brain, which is very much complex, which is superior than any machine available on the planet, is actually implementing deep learning algorithm. Now you can extract meaning from the images, you can recognize the images, you can extract the meaning from the text, you can understand the behavior, you can identify the emotions of the people. So this brain, human brain, is well equipped with these kind of algorithms which we use in our day-to-day life in order to identify or classify. So if we can implement our human brain into machine with all its complexity, then that will be the deep learning algorithms. So another example, the we can say the self-driving cars, where the car is actually detecting the obstacles and the road lane and everything. So this is deep learning under the covers. Sometimes speech recognition, image recognition, face recognition. So all these techniques or the technologies are powered by deep learning. Now this is one simple statement all about extracting the meaning from the text. I was born in Pune, and although I lived in Delhi for most of my life, I can still fluent and the blanks. So, can you tell me what will come at the place of this blank? Just answer in the chat what will be there at the blank spaces. I was born in Pune, and although I lived in Delhi for most of my life, I can still speak fluent Marathi. Okay, so very correct. So here the algorithm should be like this. It should extract the meaning from the statement. So if you can do that, that means the deep learning is actually playing role inside your brain. So your brain is actually implementing deep learning algorithms. So if you can solve this kind of expressions or these kind of problem statements where you have to fill something, even the image recognition and speech recognition, then that means we are operating deep learning algorithms under the covers, or even the self-driving cars and all. So this is all about the deep learning, which is all about implementing human brain with all its complexity and capabilities inside the machine. Now, when to use machine learning? So it's all about when, if I'm using the machine learning, then definitely we are talking about losing the jobs in most of the areas where some repetitive actions are happening, but still we are doing this. So number one is where human expertise does not exist, like navigation on Mars. So we can't send human beings on the other planets because the return journey is not guaranteed in that particular case. So but we can definitely send some robots, some rovers on the other planet, and they can behave like human beings, they can work like human beings, they can think like human beings, and they can collect very important information about that planet just like human beings. And in a simple language, they will act like human beings, and they will send very important information to our planet. And sometimes where the humans can't explain their expertise, for example speech recognition, so we can't explain our expertise in this domain. So in that case, machine learning can be used. Personalized medicine, so any personalized system, well, it can be personalized marketing strategy, there we can consider machine learning. Models which are based on huge amount of data. So as per the humans are concerned, we can deal with data, we can handle data, we can operate on data set. But if the data is huge, if we are having billions and trillions of records, then it's very much difficult for us, or it's time consuming, and it's tedious job to perform the mathematical calculations on that data. So we'll employ a machine learning algorithm, and the machine learning will deal that kind of large data within few minutes or within few seconds. Now these are some applications of machine learning that we can consider over here. So basic uh, algorithms and their applications. So the machine learning can be used for optical character recognition, it can be used for surveillance system, predictive system, smart policing, facial recognition, autonomous car, self-driving car, advertising, business intelligence, or personal assistant. Like you have seen the Google Assistant and Siri and all those stuff. So that is actually taking machine learning uh, under the covers. Or smart advertising. Let's say you search for shoes on any let's say shopping website or e-commerce website. Then after that, you will go to YouTube or any Facebook or anywhere, you will find that you are getting shoes ad. You are getting the banners and posters indicating different offers on the shoes, and they are promoting that product. So this is how they are actually understanding your interest, and based on your interest they are suggesting you different products, and they are recommending. So this kind of technique is all about machine learning. And as far as this is concerned, this smart marketing strategy is concerned, if we take a simple example of Amazon, then they are earning 35% of their total revenue from this kind of marketing strategy. So if they are earning 100 rupees, out of that 35 rupees will come from this kind of machine learning algorithm they are actually playing. So basically all these stuff, or all these are the examples, but this is just indicative examples. Not the list is very large. Of course the sky is the limit as far as the applications are concerned, but these are some of the applications you may consider. Now we need to understand what is machine learning and traditional programming. So now we do programming, so every programming is not machine learning. So we develop some softwares, we develop some algorithms, we develop some automated systems, but that is not machine learning. So basically in that particular case, these systems are rule based system. We are having data and we are having certain rules, and we program computer on that data based on certain rules that we define, and based on that the computer will generate some output. For example, if we consider temperature controlled fan, this is very simple example. So we set a rule: if the temperature is greater than 35 degrees centigrade, that is this rule. So we will define that rule, and based on these rules, whatever data we have, it can be real time room temperature which is collected from the sensor. Computer will take decision and it will turn on the fan, or sometimes it will turn off the fan depending upon these rules we are going to set. So this is traditional programming, it is not machine learning. It's all about a rule based system, hard coded system. So such softwares we can't call them as a machine learning softwares, or they are machine learning products. So we will not say such products or will not classify such product into machine learning category. On the other hand, if I say machine learning, yeah, I want to draw a simple block for the machine learning, then this is computer which is not programmed. Here we are having data when we are having output. So if I'm having some data, and if I'm knowing the outcome of it, what should be the output for these combinations of data, then I have to create or generate this rules. So the job of computers to generate or create the rules, and those rules will come from this data and output by considering, by learning from this data and output. So we'll give this data to computer and we'll say this computer, if this is the data, this will be the output. For example, I am having the pictures of dogs and cats, so I am having 1,000 pictures of dogs and I am having 1,000 pictures of cat. Now this is my data, so output will be the labels dog and cat. So I will give these labels as well as this data to the computer. So I'll say I will give this to computer, and here the machine learning model will be developed, and the machine learning model will learn from this data and their labels, and it will generate some rules to identify which what kind of object is dog and what kind of the animal is cat. So after that, once the rules are developed, then we will apply some input to the computer, and based on that rules the computer will identify whether it is dog or whether it is cat. So all this stuff, so this is the basic funda behind machine learning and traditional programming. So in traditional programming we are having the rules, we set the rules, and we just give input, and based on the whatever input we are passing, the computer will generate some result. And in case of machine learning we don't have rules, we are having the data and its probable output, and we just give that to the computer. So machine will understand all this stuff, it will do processing on the data, it will develop or it will extract some rules from it, and after that the further processing can happen. So let's take a very simple example. This is not the actual example that we are going to solve in our projects, but it's in order to understand what is machine learning. So we'll take a very simple example: automatic fan and heater using machine learning. So actually, the machine learning is not required to do this kind of stuff. It can be a simple rule-based system can help this one, but I'm trying to keep things simple. So I'll be using machine learning to do this particular simple tower to solve such problem statement. So I am having a data, this kind of data, and this is the target. So I'm collecting, maybe this data is collected. So I this is dummy data, but this data may be collected from the user experience. So maybe we can generate some Google form, and we can ask users to fill their information. If the room temperature is 5 degree, what will you do? Whether you turn on the heater or fan, what will be the status of your fan? So we'll circulate one Google form along our friends, and the friends will fill this information, and we'll ask some questions to them. If the room temperature is in this particular range, what will you do with heater and fan? So some people may say, I will turn on the heater or turn off the fan, likewise. So if the room temperature is 5 degree, these are some responses we got. Let's say this is dummy, but let's assume that thing. So in the machine learning, this is how the data will be collected from the users. So if the room temperature is 5 degrees centigrade, the heater will be on and the fan will be off, and this continues up to 20 degree. If the room temperature is 20 degree, heater will be on and fan will be off. And if the room temperature is in 25 to 35 range, heater and fan both are off. And if the room temperature is greater than this one, or it is 40 to 50 in this particular range, the fan will be on and heater will be off. So this kind of scenario is there. This way the data is there. And now we will design a smart controller or a computer. We'll just apply this data to computer, and the computer will understand meaning from this data. It is having this input. The number one column is input, and number two column, which is target, which is output. So input columns are called as independent variables, or the independent column, and the target or the output is called as dependent variable. So this is independent, this is not dependent. This temperature value is not dependent on anything, but whatever output is there, that is dependent on the temperature or on some variable. So that's how it makes it the dependent variable. Now what will happen here? So if the room temperature is in the range 5 to 20 degree, the target is heater on and fan off, and so the different cases we can consider over here. Now we have to train our machine learning model on this particular data. So we are having this data and we will train our machine learning. So before I train machine learning, let me ask you some questions. Now question number one: what will happen if the room temperature is 15 degrees centigrade? By looking at this data, if the room temperature is 15 degrees centigrade, so just answer in the chat section, what will happen to heater and fan if the room temperature is 15 degrees centigrade? What will be the status of heater and what will be the status of fan? Okay, heater on, fan off. Now it's very simple because that entry is already there in the database. But question number two: if the room temperature is 39 degree, now looking at to the data, if the room temperature is 39 degrees centigrade, what will be the status of fan and what will be the status of heater? Okay, answer in the chat. 39 degrees centigrade. If the room temperature is 39 degrees centigrade, it's this value is not there in the data set. But can you predict what will happen in that case? Nothing will happen. Okay, anything else? Okay, 39, fan on, heater off. Okay, very correct. So as it is close to this value, this particular entry is not there in data set, but still, as we know, we have to learn from this data. So this 39 is very much close to this 40. So it will be fan on and heater off. That's what we can predict. Now, next is, what will happen if the temperature is 2 degrees centigrade? Now consider this data set again, 2 degrees centigrade. So what will be the status of heater and fan for 2 degrees centigrade? Answer in the chat. Again, 2 degrees centigrade is not in. Okay, heater on, fan off, very correct. So again, the 2 degrees centigrade is less than 5 degree. So again, as the 5 degree is the cold temperature, we can say, so heater on, fan off. What will happen if it is temperature is 61 degrees centigrade? 61. Just answer in the chart. 61 degrees centigrade. Okay. Fan on, heater off. Okay, very correct. Okay, heater off, fan on. So that's very correct. So we can say here it is going beyond 50 degrees. So that's machine learning actually. So here there is no fixed rule, but what we are doing, considering this data, we are learn. So how you have answered this kind of questions. So I have asked you so many questions, these many questions, and how you were able to answer all these questions correctly. Now, very first question was very straightforward: 15 degrees centigrade. That was the entry inside our database. So there is no real magic. But for 39 degrees centigrade, for 2 degrees centigrade, and for 61 degrees centigrade, you have understood something from the data set. You have extracted meaning from the data set, or in simple language, you have learned something from that data set. You have learned the behavior of users from that data set. So this is how, if the machine can learn from the data set, just like as you have learned in a very short period of time, within few minutes you have learned from that table what should be, or you have predicted the results for 39, 2 and 61 degrees centigrade. If the machine can also learn from such data, then we can say it's machine learning. Okay, it's all about machine learning. Now we'll understand the fundamentals of machine learning. So classification of machine learning, that's what we are going to understand. History of machine learning, we are going to understand. Applications, we are going to understand. Life cycle of machine learning, we are going to understand. Then most importantly, how to get data set. Now data is nothing but the food for the machine learning algorithms. How to get such data, how to obtain data sets, that's what we are going to understand. Data pre-processing, we have already understood. In pandas library, we have cleaned our data set, we have prepared our data set in suitable form. Supervised machine learning and unsupervised machine learning, so we'll simply, or we're going to understand the basic concepts about the supervised machine learning and unsupervised machine learning. Later on, in later section, in separate modules, we are going to understand all about supervised machine learning. We are going to understand everything about unsupervised machine learning with some algorithm and practical implementation of all these techniques. So right now we'll deal with these points, and with these points we'll understand basics of machine learning. So number one is classification of machine learning. Machine learning is classified in three major categories. Number one is supervised learning, unsupervised learning, and reinforcement learning. I'm not talking about AI. I'm not talking about deep learning. I'm talking about machine learning, which is the subset of AI, and deep learning is the subset of machine learning. But as far as the machine learning is concerned, it is classified in three major categories: supervised, unsupervised, and reinforcement learning. So we'll understand all these terms. How, what is the architecture of supervised machine learning, what is the architecture of unsupervised and reinforcement learning. Now, as far as the history of machine learning is concerned, it is originated in 1956, as I said. So, initially, the job or the objective was to just mimic the human behavior in some way inside machine. After that, after 1980s, we are talking about machine learning, where we are implementing learning ability of human beings inside the machine. And after 2010, we are talking about deep learning, where we are trying to implement human brain with all its complexity inside the machine, with all its capacity, capabilities, powers, and complexity inside the machine. And if we can develop human brain inside the machine, that will be deep learning under the covers, like self-driving cars. Now it's under the development. This technology is still in the young age, but soon we will implement all these stuff. Whatever we see in the Hollywood fiction movies or in the sci-fi movies can be implemented, or it can be the reality. Now we see, we generally we say about this is the age of machines, and the machines are going to control the planet. So this thing will happen. Nowadays, even you can find some bots on the social media, like on Facebook. Instead of real human beings, the bots are, somebody has created bots, and that bot is actually operating their Facebook account. The bot is sending the friend request. The bot is posting on their Facebook account. So bot, there are, you may have seen the number of bots are there on the social media, and we really have to identify which is the real person and which is the bot. So all this stuff is under the deep learning, where actually it is under the covers, and it is actually playing a very major role. Now, as far as the applications are concerned, image recognition, speech recognition, traffic prediction, so many applications, self-driving car, email spam filtering, all this stuff, even the bot identification in the social media, personal assistant, fraud detection, language translation. So we have seen all this stuff. So all these stuff, these we have experienced, or we are taking advantage, or we are making use of such technologies like uh, understanding all about the image recognition. We use speech recognition, Google speech recognition we use, even Apple Siri we use, traffic prediction systems we use. Google Maps actually predicts the traffic and traffic jams. So all this stuff falls under the machine learning category, and we actually use all these things. So these are just applications. We are actually using machine learning in our day-to-day life, but now as a part of this course we have to develop all these techniques. Life cycle of machine learning. So here how this will happen, or how we will solve any problem using machine learning. So number one step is gathering data. Data set is very important. Data is the food for machine learning. So you should have data, because machine has to learn at its own, and in order to learn from it needs some data, previous data. So we should have some data and data set, and we will feed that data to machine. Machine will understand that data, machine will extract meaning from that data, machine will learn from that data, and once machine is learned, after that further thing will happen. After that it will predict result for any new thing, or whatever new input it will give it to you. Data preparation. So you should prepare data in a proper format. If it is in the CSV format, then you should load that. It should be prepared in data frame and all. For that, pandas library we have used. Data wrangling, it's all about cleaning the data now, or the preparing data in suitable form, so that we will add some value to our data set. For example, we have loaded the CSV file. There are a number of duplicate entries are there, some empty cells are there, some wrong format data is there, or some wrong data is there. All such data has to be cleaned, processed. So all these stuff is all about the data wrangling or cleaning the data. Analyzing data is the next step. Now what is analyzing? We should understand what kind of data is there, whether it is linear data, non-linear data is there, or how many variables are there which is affecting the output column. What is the similarity, correlation between the different input features or the columns. So this is all about the analyzing data, how many entries are there, and what kind of data is there. So we should understand something about data before we choose the algorithm for machine learning. Otherwise it will be a error and trial kind of thing. So you choose one algorithm, it's not producing good results, so go for another. Again it's not producing good, then again choose different one. So this things is not required in machine learning. You should be very specific what you have to use. You should understand your data, what kind of data you have, whether it is linear data, non-linear data. If it is linear data, you can go with the regression, whether to go with the regression, whether to go with classification. So as far as the machine learning is concerned, we will understand that thing later on. But as far as the supervised learning is concerned, we can classify in terms of regression analysis and classification problem statement. So whether your output is a category or some class, or whether your output variable is some value, based on that you will have to choose regression or classification algorithm. So for that you must analyze your data, and after analyzing data you will choose a particular algorithm or a model, and after that you will train that using that data, because the data is now prepared in a good format. Now we have added more value to our data, and now our data, our machine learning model will be trained on our clean, filtered, and more valuable data, because the data is the food for machine learning, and that food has to be it must have some quality. If the food is not having good quality, obviously the human body will not behave, or will not yield the expected results, or it will not perform as expected. Similarly, if the data is not good, if it is not in proper format, if it is not cleaned, if it is not processed properly, or if it is not analyzed properly, the machine learning model will not perform, or will not uh, actually generate the proper result. So that's what we need to understand all about these things. After that we will train the model, and once the model is trained, we will test our model. Now training is important. We'll find out the what is the accuracy during the training. Once we get that this model is having good accuracy on training. Now what is training and testing? Training means known data. So you train your model on known data. For example, you have to train a small child. You have to teach English alphabets A to Z. Now, what you will do, you will draw a letter A and you will say that this is A. So that child will understand that this is A. Again, you will draw a picture of A and you will say this is A. So many times you will use data. So let's say you are drawing A for 5 times and again B for 5 times and so on, Z for 5 times. So this is your training data. So you are training 5 times or 5 iterations actually you are doing there. Now the child will understand everything, that this is A, this kind of figure is English alphabet A. Now this is training data. Now what you will do, you will show random picture from that training data sets, whatever you have drawn now, from that only you will show, and you will ask that child what is this. If the child responds that it is A, B, C, D, whatever, so you will give known data. If you are evaluating your model on known data, so that will be training accuracy. So during training, whatever data you are using, and if you are choosing some random data from the training data set only, and if you evaluate the accuracy, how accurately it is predicting on the known data, then that is training accuracy. Coming back to our previous example where I have shown you data set of temperature versus fan and heater. So firstly I have asked what will happen to 15 degrees centigrade. So 15 degree was the known data which was there in the data set. So that is the training the model on that data and evaluating the accuracy or the performance measures on that training data. If you ask you questions from the data set itself, that will that and if I check out your accuracy, that will be training accuracy. Now test accuracy is something different, or testing the model is something different. Now testing means once the model is trained, now I will give unknown data to the model as input. That is the final objective. You should give unknown data. For example, I have asked you what will happen if the temperature is 61 degrees centigrade. Now this entry was not there in the data set. This is completely unknown. But your brain is trained in such a way that, or you have learned in such a way that, even if some unknown entry is given, internal mathematics is adjusted, or you have developed some mathematical equations inside your brain. Even if the or logically you have understood all everything about that data, even if you are asked about 61 degrees centigrade, you have predicted correctly the status of that fan and the heater. And this is all about testing the model. You should give unknown data. If you give unknown data, at that time we will calculate the performance of our model, and that will be the testing accuracy. So our training accuracy has to be good, and as well as our testing accuracy should be good. If both the accuracies are very good, then we will say that the model is ready and it is now capable of predicting whatever input you will give in that particular domain. And after that, step number 7 will come into picture, deployment of that model. After that, we will deploy the system. So we should get good training accuracy as well as good testing accuracy. If you are getting good training accuracy but not the good testing accuracy, that means your model will perform well for the training data, but it will not perform well for the testing data. So that will be overfitting and underfitting concepts of model that we'll see in actual programming or in later modules. And if your model is not performing even for the training data and even for the testing data or unknown data, that means your model is of no use. Okay, so again, that's what we are going to understand: how to train the model, how to evaluate the performances of that model, how to understand about the accuracy, confusion metrics, and all those things. Some performance measures we can use, and accuracy, confusion metrics, F1 score, and all those stuff we will understand in programming. Now, next is how to get data set. As I said, the step number 1 is obtaining the data sets. Now, how to obtain data set? Now, there are so many websites are there, so many platforms are there from where you can actually get the data for the machine learning. So, number 1 is Kaggle dataset. Then UCI machine learning repository is there, that is number 2. Dataset via AWS, Amazon Web Services. Google's dataset search engine is there from where you can actually obtain some dataset. Microsoft dataset is there. Even the awesome public dataset collection is there. So there are so many platforms from where actually you can obtain some dataset for your machine learning algorithm. Government websites are there from which you can actually obtain some data set, and even the computer vision data sets are available. Scikit-learn data set is available, and all these are some platforms from where you can obtain data set. Now, how the data set is collected and how they are hosting data set. For example, Kaggle, they're having the lots of data set. You can go there on the Kaggle's website and you can search for some data set. You will find so many data sets. Or even the UCI machine learning repositories, there you can find some data sets over there. Basically, they are collecting data sets. Let's say for the brain tumor detection, they are collecting data sets from the hospitals, and they are storing that data set, or they are hosting their data set. If you do not find data set for your machine learning or for your problem statement online, okay, if you do not find dataset online, then you will have to prepare your own dataset. Okay, so for example, for particular thing you do not get any dataset online, so all these are the some sources of dataset like Kaggle, UCI, AWS, Google's dataset, Microsoft awesome government datasets, computer vision dataset, or even the scikit-learn dataset. If you do not find dataset online, then you will have to prepare your own dataset. Now, how you can collect your dataset? You may be circulating Google Forms, and you may ask users to fill information. Now they will fill some, there will be some questions, and they will answer those questions, and you can prepare your data set. Or you can, as a shopping complex or as a shopping mall, they may collect data of their whatever the customer coming over there. For example, in a mall, whenever you purchase something, they will ask your mobile number and other stuff, and of course they will get to know whatever items you have purchased at the time of billing. So they will prepare your data in CSV format, and they will analyze that data. They will extract meaning from that data. They will understand what kind of items you are purchasing. They will understand your interest, and based on that they will promote certain products to you. So this is how the data is collected, data is prepared, and it is processed, analyzed, and then the model will be trained. Okay, my screen is visible now. uh, Now I have changed that machine learning lifecycle slide. Now I am on the types of machine learning slide. Is it visible? Just answer in the chat section. Okay, fine, good. So, the types of machine learnings. So, number one is supervised learning, number two is unsupervised learning, and number three is reinforcement learning. So, as far as machine learning, I'm talking about machine learning, not about artificial intelligence and not about deep learning. So, as far as machine learning itself is considered, it is classified in three major categories. Number one is supervised machine learning, unsupervised machine learning, and reinforcement machine learning. So, these three are different techniques, different algorithms, and they can be used in different cases, different applications are there. But majority is supervised machine learning. So majority of problem statement you will come across, or the majority of machine learning softwares you will find, or the programs you will find, they are developed under supervised machine learning category, and that is of course the most accurate method also. Sometimes the supervised machine learning cannot be used. In such cases, unsupervised machine learning and reinforcement learning can be used. So now let's understand what is supervised machine learning in very simple language. For example, you have to identify some apples and bananas. So you have the data set of the images you are having. Some images are of apple and some images are of bananas. Now you can see here there is this data set, and in this particular data set there are some apples and there are some bananas. So you have so many pictures of apple and so many pictures of banana. Now you will understand, or somebody is there who will teach you that this is apple, this is banana. So that means somebody will give some labels. So in other words, some teacher is there who is teaching you that this is apple and this is banana. Okay, just understand, this apple, this is banana, this fruit is called as apple, and this fruit is called as banana. So just like that small child, you are teaching how to identify fruits. So you will show some picture of apple and you will say that understand this is the apple and this is the banana. So you are teaching small child, this is apple, this is banana. This time you have the labels, apple and banana. This is called as labels. Now you have some labels and you are teaching. So if some teacher is there who is supervising the teaching process or this learning process, then that is supervised machine learning. So here we are having labels as well as the data inputs or some data values in our data set. Now this ML algorithm, there could be some algorithm, maybe regression analysis or maybe classification problem statement. So we'll discuss that later on. But some algorithm, some software, some code, some technique will be there which will teach this model on this data set and using these labels. And now the model will be trained. Now that child will be trained, that you are teaching that child this is apple, this is banana. Now the child will understand everything, and now the child is trained. Now we will give any unseen data, unlabeled data. So we'll what we'll do, we will just ask that child, we will take that child to, let's say, market, and we'll pick some fruit from that. We'll ask what is this, or we will, in other words, we will ask that child to go into the market and purchase some bananas. Now the child will go into market and he will see where the banana is there, and what stall the banana is there, where the apples are there. So the child will understand this is the apple, because it will predict that this is apple and this is banana. So if we have asked him to purchase apple, then he will purchase apples only. Why? Because the child is previously trained on some data set. So we are having apple and bananas, and we have trained that child on that particular data set, and then it will predict. So this kind of architecture or this kind of process is called as supervised machine learning. If some teacher or somebody is supervising, so here, as we are having the labels, we are supervising everything, all about the training. During the training phase, we are supervising how the model is getting trained, because we are having the labels, and of course we are having these images. So this is supervised machine learning. On the other hand, here the problem is in this particular slide, which is unsupervised machine learning, which is completely different than the machine learning, the traditional machine learning or the supervised machine learning. Here the fruits are mixed in a bucket. So let's say we are having a box, and inside that box we have, let's say, as a parent, we have purchased so many fruits, and I have packed all these fruits in a box, and I have just given some task to my child, that you will have to identify or just sort all these fruits, make these fruits different, this different, and all this different. So this time I am not having labels, or I am not giving any input to that child that this is the apple, this is banana. So labels are not there. This is unlabeled data. The whatever items we are having, whatever data we are having, doesn't have any kind of label. So what will happen in this particular case, the child will understand that data, it will pick similar object. So let's say this red color object, it will pick, and it will pack this into, or it will put that particular red colored fruits in some different box, or it will sort that in different box. Then this green color watermelons, that child will pick all these objects, and he will put in some different box. Now it will sort. So this is how some clusters will be made from the data. So we are having data which is mixed, which is not having any kind of labels like previous one. This time the job is to form some clusters of some groups, forming some groups. So machine learning model, here the job of this model is to identify, understand the data, this mixed data, and to form clusters or groups. So many groups it can form. So this is group 1, group 2, group 3, and it will label every group as group 1 or cluster 1, cluster 2, cluster 3, cluster 4, up to cluster n. So this is how it will sort the data. And if such kind of clustering is happening, and this kind of data is unsupervised machine learning data. Now the example that I was giving to you, like you collect the information from the customers in shopping mall. Let's say they will collect your mobile number, your email address, and whatever items you have purchased. Now all the customers will be there in single data set, but there is what we have to calculate, the interest, the final outcome label we have to calculate. So group 1, group 2, group 3. So we'll categorize, or we'll sort all these customers. Let's say we collect information of 10,000 customers who are visiting the mall. Some people are purchasing clothing, some people are purchasing electronics items, some people are purchasing grocery items. Now what we will do, from this particular entire data set we will form some groups. So this group of people are more interested in grocery, these group of people are more interested in electronics product, and this group of people are more interested in the clothes. So likewise we'll sort, and this kind of problem statement can be solved by using unsupervised machine learning model. So this is all about the unsupervised machine learning. And the last one is reinforcement learning. So this is actually error based learning, learning from the mistakes, learning from the errors, or learning from the feedback, or learning from the experiences. So here, if this input is given to the child, let's say this computer is a small kid or child, so we give this in image as input, then we ask, so if it predicts mango, we'll say no, it's not the mango, it's the apple. Now the child will understand that this kind of thing is not mango, this is the apple. So response versus feedback, so we give some response, then we'll give some feedback, we'll get the feedback from the machine. Now the child will learn, okay, it is noted now, so now it's not this kind of fruit, is not the mango, it is apple. Now the child will learn. So this is how, from the experiences, from the data, and from the response and feedback system, or from the error and trials, this kind of machine learning algorithm will learn from the inputs. And once it is learned, then the model will be prepared. This is the final model. Now the input will be given to this model, and now this will predict whether it is apple or whether it is banana, or whatever we want to predict. So this is reinforcement learning. It's all about giving some responses, generating some responses, analyzing that response whether it is correct or not, giving some rewards or penalties. If the response is correct, we'll give reward. If the response is wrong, then we'll give penalty. With the help of that, with the help of all these rewards and penalties or the feedbacks, the model will learn itself step by step, and the responses or this will be noted, and it will learn just like human beings. As we learn from our past mistakes, we as a human being, we make so many mistakes in our day to day life, and we learn from our mistakes. And once we learn from our mistake, next time we will not repeat that mistake, because we have learned from, we have received some feedback, some kind of penalty for our mistake. So next time we will not do that mistake. For example, if you break the traffic signal, the traffic holder will catch you and will ask you for the fine. So you will have to pay some fine there, and once you pay some fine, next time you will not break the traffic signal, because you know, if I break that, I will have to pay some fine. So this thing, in this particular way, the machine gets learned. If it is getting learned like this way, then this is reinforcement learning. So this is all about the fundamentals of machine learning, all about the basic concepts of machine learning. Hope you have understood all this stuff, the basic terminologies, basic definitions of machine learning: supervised machine learning, unsupervised machine learning, reinforcement learning. I hope you have understood the differences between the AI, machine learning, and deep learning. So, from the next lecture and onwards, we are actually going to implement all these stuff using some programs. So, we'll get some data set, we'll operate on that data set, we will solve some real time day to day life problem statements using machine learning. And whatever techniques I have just described to you, we will try to implement each and everything, or this all these techniques, programmatically using some Python programs, and also by making some use of some libraries. Of course, NumPy, Pandas, and Matplotlib we are going to use, and few more library like scikit-learn or OpenCV for computer vision, or for the NLP we are going to use different libraries. So by making use of such libraries, we will solve our problem statements, and we will implement machine learning software. So we'll conclude with today's session, but we will wait for some time in the chat section for your queries and doubts regarding the today's session.